Determine if the series converges, and if so, whether that convergence is absolute or conditional. I see that we have an alternating series, so the first thing I'll try is the alternating series test. So we want to know two things. First, is the series without the alternating part, 1 over n, is this decreasing? Second, is the limit as n goes to infinity of 1 over 1 plus n 0? If it passes these two, then we know that the series converges. So as for the decreasing part, if we were to compare a n plus 1 versus a n, well, a n plus 1 is 1 over n plus 2. We want to know whether this is bigger, smaller, or equal to 1 over n plus 1. Now, the term on the left has a larger denominator than the term on the right, so the term on the left is smaller. So we can say, yes, a n plus 1 is smaller than a n, and so we know that 1 over n plus 1 is decreasing. Next up, if we take the limit, this is of the form 1 over infinity, so yes, the limit is 0, and since we know that the series converges. However, we use the alternating series test to do this, so we need to test whether the series converges conditionally or absolutely. So conditional convergence versus absolute convergence. So now we're going to test the series again without the sign change. So we will modify this as our new series, 1 over n plus 1, and test this again. This is no longer alternating, so we can't use the alternating series test. We've got to use something else. So I see this looks like, if we ignore the all but the highest powers of n, this looks like the sum of 1 over n. So it looks like this p-series with p equals 1. So to test this, we'll use the limit comparison test. We take the limit as n goes to infinity of the series we're testing, which is 1 over n plus 1, divide that by the series that we know the status of its convergence. So we can rewrite this limit as the limit n goes to infinity, 1 over n plus 1 times the reciprocal, which is n over 1. And this gives us the limit as n goes to infinity of n over n plus 1. This is of the form infinity over infinity. We can apply L'Hopital's rule and we get that the limit is 1. Since we got a positive number for our limit, that says that these two in fact are equivalent. If one converges, so does the other. And the series on the right diverged because it's a p-series with p equals 1. That tells us that this series also diverges. That says it does not converge without the sign change. So it is not absolutely convergent, so the convergence is conditional.